So in this situation, we see we have a graph. So we're going to go right at the Oyzerga. O, Y, X, I, R, G, A. So the origin is here for all of them. The y-axis for all is the potential energy. X-axis for all of them is the time. The intercept is going to be varied depending on the graph. What we can read is potential energy and time. The slope is going to be the potential energy over delta t, which is the power, it turns out. It's the rate of change of energy. And the area is going to be potential energy times time, which doesn't seem to be something that jumps right out at us as a quantity. So now we know the situation. A ball is thrown vertically upwards, and it comes down again. Air resistance is negligible. Good. So let's see. What do we know here? Well, let's go on and read the question. Which of the following graphs show the gravitational energy varies with time? Well, at the beginning, the potential energy is 0. And at the end, the potential energy is 0. Let's see if we can put that to use for us. Well, in choice A, the potential energy in the beginning is not 0. So choice A is out. Choice B starts at 0 and ends at 0. Choice C starts and ends at 0. Choice E starts and ends at 0. All three of them have a maximum in the middle, and they generally follow the same increase then decrease pattern, but the devil's in the details about how the slope is changing. So let's look a little more closely at the slope. The slope in the first one starts out small, then it increases, gets to a maximum, then it decreases and becomes 0. So if we were to assign numbers to those, we say that one's 0 at the top, and this might be 1, and this would be 2, and this might be 3, and this might be 2, and that's 0. So we see increase and decrease, and then we have change on the other side where we've got a -2 and a -3 and a -2 and a -1 in that case. So we see the slope is increasing and then decreasing to 0 at the midpoint, and then it increases and then decreases to 0 again. Whereas choice C, we have a constant slope. The rates of change are constant. And with choice D, we have almost exactly the opposite of B. We start out with big positive slopes and they decrease to 0. So this might be 6 and 3 and 2. And then we have -2, -3, -6. So what this says is the biggest change for choice E occurs at the very beginning and the very end, the biggest rate of change of gravitational potential energy. And in choice B, the biggest rate of change happens in the middle, and it's very small at the ends and in the midpoint. So let's look at the slope in more detail. We have the potential energy is going to be mg delta z all over the change in time. Now this delta z over delta t we should recognize as meters per second, so it's the velocity. Oh, it's the velocity. And remember, we also said that the gradient is power, and power equals FV. So from 2 lines of evidence, that there's something about the velocity. So when is the velocity going to be the greatest? Well, since the velocity is directly related to the rate of change of energy, choice C says the velocity stays the same the entire time. Well, that can't be true when we throw something up and down, so choice C is out. And if we look at choices B and D, they have opposite statements about the beginning. Well, when you throw an object up, it has its highest velocity, and then that velocity decreases to 0. The velocity doesn't increase and then decrease again on its way up. And so that is why choice D is our best